Coulomb's law. What do you mean by Coulomb's law? Coulomb is a scientist who has explained about the force exerted by the charge and between the two charges depends on its distance as well as magnitude of the charges. Okay, how does it? He has explained. This is also we call as inverse square law. Inverse square law. Square law. Of course, you might have seen inverse square laws in other mechanics part also, in gravitation. Okay, Coulomb's law. What do you mean by Coulomb's? Coulomb's is a scientist, and his name, who has derived that after this, and his name it has come. What is the Coulomb's law? According to Coulomb's law, the electrostatic force of attraction between two charges. Electrostatic force of attraction between two charges is directly proportional to product of those two charges and inversely proportional to square of the distance between them. Inversely proportional to square of the distance between them along the straight line. Along the straight line. Why I mentioned the word along the straight line, I will get back to you later. So, the electrostatic force of attraction F between any two charges is directly proportional to product of those two charges and inversely proportional to square of the distance between them. From these two equations, if you are written this, F is directly proportional to Q1, Q2 by R square. Therefore, I can also write this further. Since F is directly proportional to Q1, Q2 by R square in the sense, if I remove the proportional, I have a constant which is called as K into Q1, Q2 by R square, where K is a proportionality constant. Proportionality constant, which is equal to 1 by 4 pi epsilon naught. It is in free space I am talking, or in vacuum I am talking. Okay, that is equal to 9 into 10 to the power of 9, the value. From this, if you are making the subject, you will have the units there. Therefore, this equation further we can write off F equal to 1 by 4 pi epsilon into Q1, Q2 by R square. Okay, so of course, if you make this as a subject, you are having here Newton meter square or Coulomb square as the image for that. So this is a formula for force acting between any two charges. Which force? Electrostatic force acting between any two charges along the straight line. Okay, this charge, this force, this changes depends on the magnitude of these two charges. Okay, here I have taken same nature of the charges. It depends on the positive and negative, and both are negative or both are positive. If both are positive, both acts the charge is outward. That's why I kept the directions outward direction, since both are positive charges. Nothing is there means consider it as a positive charge. Okay, I said along the straight line in the sense, since it is a central force. What is the force acting between the two charges? It is a central force. Okay, means center of the charge to center of the charge impacts. It always joining along the line of the forces between two charges. The force acting between two charges is independent of the charge which is placing at that area. If I place Q3 will not affect the force acting between these two charges. It may have the force between these two or between these two, but Individually, it will not affect the force which is between these two. Got my point? At the same time, whatever the force is there between these two will not affected by this force exerted by this charge. Okay, this is nothing but Coulomb's law. Coulomb's law applicable for microscopic charged particles always. Okay, Coulomb's law applicable for microscopic charged particles. Coulomb's law obeys Newton third law. Because if this force is acting outwards and opposite to that, this force is also acting outwards, then we can write force exerted by the charge 1 on 2 is F1 2, force exerted by the charge 2 on 1, F2 1, with the opposite direction, F1 2 equal to minus F2 1, we can write. Okay, this is nothing but a characteristics of Coulomb's law. Coulomb's law of the electrostatic force which is acting in the Coulomb's law is central force because center to center along the line joining it is acting. And this is a force, is a conservative force. Since it is a central force, this force is also as conservative force. What do you mean by conservative force? We were having discussion conservative force in the mechanics. Conservative force is a force which is force exerted, work done by the force around a closed path equal to 0. Work done by a force around a closed path equal to 0. That is we call as conservative force. Okay, this is all about the Coulomb's law. Coulomb's law affects or changes depends on if force is directly proportional to product of two charges in the sense magnitude of charges if it changes, then the force increases. If since it is inversely proportional, inverse law, if the distance is increasing, then there is a force changes. One most important thing is that you are seeing this epsilon naught. This is nothing but we call as permittivity of free space. What is that? Permittivity of free space, which describes about the medium in which you are finding this force. For example, these two charges kept in air or in a free space you are finding, then the value is epsilon naught. Epsilon naught equal to, we have the value that is 8.85 into 10 to the power of minus 12. Minus 12 Newton meter square. Sorry, epsilon value can be written as Coulomb square per Newton meter square. This is a value of 8.85 into 10 to the power of minus 12. This is for the free space. Epsilon naught is a word, it's a letter we'll use for the free space. Epsilon is for the medium. If the same two charges I kept inside the water, I am finding the force between them how much. Or I kept in a turpentine oil, I kept in any other mercury and I am finding what is the force between the two charges. Then depends on the mediums, the force changes here. Okay, this is all about the basic Coulomb's law, right? Now, most important thing here we need to address as per our IBDP profile, we have TOK, right? Theory of knowledge from this topic you can understand here is the TOK is the idea. In this, what is the TOK connection? You should know it. Is the idea of the field human construct, or does it reflect the reality of universe? Is the idea of the field, means whatever we are talking about the field, electric field and forces due to the charge, is it real? Is it reflecting in the real world or in the universe? Is a question. Understand? Apply it. Are you getting my point? Is the idea of the field human construct, means is that constructed by human, or does it reflect in the universe? Really, naturally, it is there. Is it available for us? This we have
Okay,
to
sir.
understand. We have to think about that. Just not answer it. Is construction of human or is it the existing field? If it is existing, why can't we see? Why can't we affect? If it is affecting, how it is? That we should understand as a the TOK application from this topic.
Okay.